We pretty much hit the jackpot with Earth, as even up to this day, we are yet to find the existence of life on any other planet. And yet, we go about our daily lives taking our blue, water-rich utopia for granted, never imagining what would happen if the Earth just stopped. Recent studies revealing that the Earth's core is slowing and cooling down might make you want to fasten your seatbelt. What if the Earth stopped spinning? What would happen to our planet and our humanity? You don't have the answers? Well, you're in luck, because in today's video, we take a look at the Earth's core, why it's slowing down, and what would happen if it stopped completely. You don't want to miss this. It's not every day you hear that the Earth's core is slowing down. Well, anything of that magnitude can sound scary right off the bat. For us to understand the implication of that news, we first need to understand what the Earth's core is. Contrary to popular belief and some famous disaster films, no one has ever traveled to the center of the Earth, so we don't know exactly what the Earth's core looks like. But geophysicists have an idea based on seismic data from earthquakes, magnetic field research, meteorite analysis, and computer modeling. From their calculations, they've concluded that the Earth's core is located about 2,900 kilometers or 1,802 miles beneath the Earth's surface, with a radius of about 3,485 kilometers or 2,156 miles. That's bigger than Pluto. Think of the Earth as an egg, and the core the yolk within it. Except this yolk is made of iron. As you may have imagined, the Earth's core is very hot and dense, with three main layers: a solid iron inner layer, a molten iron outer layer, a mantle, and with that, a thin crust separating the core from the rest of the Earth. As you may not have imagined, our planet didn't always have this solid iron core. When our planet was formed billions of years ago, it was a homogeneous ball of molten rock. But following radioactive decay and leftover heat from the planetary formation process, this ball got hotter. Fast forward to 500 million years later, and the temperature of Earth increased to the melting point of iron. That's about 1,538 degrees Celsius or 2,800 degrees Fahrenheit. This phenomenon, known as the iron catastrophe, led to the rapid movement of Earth's molten material, with buoyant materials like silicates, water, and air staying close to the planet's exterior and forming the crust, while heavier materials like iron, nickel, and other heavy metals descended towards the center, forming the core. So now that we are up to speed on the core details, pun intended, why is all of this so important? The formation of the Earth's iron core and the more global separation of elements known as planetary differentiation is thought to be the main reason why life thrives on Earth. Earth's core is important as it is responsible for the generation of the planet's magnetic field. More precisely, the magnetic field is created by the outer core. Here, the molten iron's convective energy is transformed into electrical and magnetic energy. Working in a positive feedback loop, the electric currents create their own magnetic field, which in turn creates more electric currents. Earth's magnetic field is generated from its core and extends from there into space, creating a region around the planet known as the magnetosphere. Without it, we would be unprotected from cosmic rays, the solar wind, and particle radiation, all of which have the power to erode our planet's life-supporting atmosphere and end life on Earth as we know it. For an idea of what would happen if this magnetosphere didn't exist, you just need to look up an image of Mars. Doesn't look too good, right? Okay, we get it. The core is a pretty big deal. But what's all this talk about spinning? Once again, we have to start from the beginning. How did our planet start spinning? We can't be sure because no one thought to bring their phones and record this major event, amateurs, but the scientists believe that a large object, around the size of Mars, collided with a young Earth billions of years ago during the formation of the early solar system. This collision is believed to have caused a chunk of Earth to break off, forming the Moon, and ever since, our planet has just been spinning. Scientists also believe that at some point, the Earth was spinning so fast that one Earth day was only 6 hours long. Right now, the Earth is still spinning, but clearly we've slowed down substantially in the last few billion years. How many more years can we continue to spin? The Earth still spins from that initial collision due to inertia. Although the Moon, Sun, and other planets in our solar system provide forces that oppose Earth's rotation, these forces are not sufficient to bring our planet to a full stop. So it seems we have a bit more time to reflect on this spinning situation. However, scientists recently discovered that as of 2009, the Earth's inner core had slowed down significantly and is currently rotating at a slower pace than the rest of the Earth. To determine this, they examined seismic waves that had happened on Earth at various times throughout history, and for which measurements were available that tracked those waves from one side of the Earth to the other, traveling through the core on their way. While it was expected that near-identical earthquakes would show similar patterns across the globe, the data analyzed showed differences in waveform and travel time, allowing scientists to make inferences about the rotational speed of the inner core. In other words, it definitely slowed down. To top it off, remember our whole bit about the inner core being almost as hot as the surface of the sun? Well, it's still very hot, but nothing has been heating it since its formation, so it's just losing heat every day. Technically, the Earth's core has been cooling down for billions of years. And now these Earth scientists confirm that cooling is happening at a rate 1.5 times faster than previously calculated. Like we didn't have enough to worry about already. A faster cooling rate means that the hot, molten core of the Earth will solidify sooner than expected, resulting in the cessation of all geological activity on Earth. Again, we end up with no magnetic field, an assault of cosmic radiation, and a resurfacing of the planet, leaving us as barren as Mars. But before you go outside to check if our planet has stopped rotating, it turns out that some of this has happened before. So the inner core cooling and slowing down isn't to be blamed for rising fuel prices and will probably not lead to the end of the world. Well, not just yet. Apparently, the evidence shows that the Earth's inner core not only slows down, but occasionally also speeds up, and that this fluctuation in speed relative to the rest of the planet is actually periodic, happening in 70-year cycles. Well, what do you know? The Earth's core slowing down isn't as cataclysmic as it sounds. Okay, but what would happen if the Earth stopped rotating completely? Firstly, a still Earth that continues to orbit the Sun would have a day that is equal to 1 year, where the daytime you'd experience would last for 6 months, and the nighttime you'd experience would last another 6 months. Yikes, this sounds so tiresome already. That would mean everyone living on the day side would experience increasingly hot conditions, and everyone living on the night side would be in a deep freeze. That is, if the land you were living on even stayed put. The rotation of the Earth causes the planet to slightly bulge at the equator. If Earth suddenly stopped spinning, the oceans would very likely disperse toward the poles, leaving a giant continent at the equator. This massive shifting of land and sea would cause tremendous friction, leading to monstrous earthquakes, tsunamis, and volcanic eruptions. And remember our magnetosphere that keeps out cosmic rays and solar radiation, allowing life to exist on Earth in the first place? Yep, we'd lose that too, leading to the slow extinction of all life on Earth. Oh wait, there's more? If the endless stream of natural disasters and the solar radiation somehow doesn't destroy all life on Earth, then you can imagine that the lack of a 24-hour day will. Our whole rhythm would be off. Imagine how long you'd have to be at work. And not just us. Every species on this planet, whether it be plant, animal, or microbe, depends on the 24-hour circadian rhythm for its continued existence. For example, plankton that needs sunlight for photosynthesis wouldn't stand a chance in 6-month long nights. and since they form the bottom of the food chain, the trickle-up effect would be devastating. Okay, so the bad news is that the Earth is definitely slowing down and cooling down, and our inner core is doing its own thing. But the good news is that the Earth's rotation is slowing down at a very leisurely pace. During the Jurassic period, dinosaurs roaming the Earth experienced a 23-hour day and roughly a 385-day year. It's taken about 180 million years for us to slow down by 1 hour and reach the 24-hour clock we all know today. In the last 100 years, the Earth has slowed down by a whopping 1.4 milliseconds, meaning our days have gotten 1.4 milliseconds longer and continue to get longer by mere fractions of a second every day. Well, at least now you have a good excuse when your boss asks why you're so tired. This is why we occasionally add what is known as a leap second to the clock. Leap seconds were introduced back in 1972, and thus far there have been 27 added at occasional intervals. The last leap second was added to the clock back in 2016, and the next is being considered for this year, December of 2023. It will be at least another 180 million years before we have to adjust to a 25-hour clock. Considering the number of other predicaments that have the potential to wipe out human existence in that time, you shouldn't lose any sleep over the Earth slowing down. In fact, you might consider basking in those extra few nanoseconds of sleep each night. Would you like to have 25 hours in a day? Let us know in the comments.